You're listening to the N2K Space Network.
At Thales, they know cybersecurity can be tough and you can't protect everything. But with Thales, you can secure what matters most. With Thales's industry-leading platforms, you can protect critical applications, data, and identities, anywhere and at scale with the highest ROI. That's why the most trusted brands and largest banks, retailers, and healthcare companies in the world rely on Thales to protect what matters most: applications, data, and identity. That's Thales. Thales. Learn more at thalesgroup.com/cyber.
Today is November 6th, 2025. I'm Maria Varmazes, and this is T-Minus.
T-Minus. 20 seconds to LOS egress. Go for deploy. Rock and roll.
Portal Space Systems has introduced a new spacecraft, which they plan to launch to orbit in 2026.
4.
Starcatcher has set a new world record for wireless optical power transmission.
3.
Reflex Aerospace has closed a €50 million Series A funding round.
2.
Kratos Defense and Security Solutions has signed a definitive agreement to acquire 100% of the ordinary shares of Orbit Technologies for $356.3 million.
1.
EchoStar to sell a set of wireless spectrum licenses to SpaceX for about $2.6 billion. Our guest today is Yanni Barghouty, co-founder and CEO of Cosmic Shielding Corporation, and I caught up with Yanni to hear about how AI-enabled chips in space can lead to space-based data centers and significant cost savings for satellite operators. Definitely stick around to find out more about that after today's headlines. Thank you for joining me on this Thursday, everyone. Let's dive into our Intel briefing. So, what do you call a company that keeps buying up all of the spectrum licenses? A conglomerate, of course. No, that's not a weird joke. It is simply a fact and an accurate description of SpaceX, with the news that they plan to purchase more licenses from EchoStar. EchoStar said that it would sell a set of wireless spectrum licenses to SpaceX for about $2.6 billion in exchange for stock in the space startup, expanding on the $17 billion deal that the company struck back in September. So what spectrum exactly is on offer in this deal? EchoStar says it'll sell the AWS-3 licenses, which cover airwaves across the United States that can be used to support mobile and satellite communications. And we should add that SpaceX is not the largest buyer of spectrum from EchoStar to date, as that accolade is owned by telecommunications giant AT&T, who agreed to acquire 50 megahertz of nationwide mid-band and low-band spectrum for $23 billion earlier this year. Anyway, back to SpaceX. EchoStar CEO Hamid Akhavan said in a statement that by combining EchoStar's wireless airwaves with SpaceX's rocket launch and satellite manufacturing capabilities, they can quickly create strong and affordable direct-to-cell services. And that is certainly a key objective of the latest generation of Starlink satellites. The sale to SpaceX will close after receiving regulatory approval. Kratos Defense and Security Solutions has signed a definitive agreement to acquire 100% of the ordinary shares of Orbit Technologies Limited for $356.3 million. The acquisition is expected to be funded via cash on Kratos' balance sheet. And Orbit Technologies is a leading global provider of mission-critical satellite-based communication systems for mobile and unmanned aerial, seaborne, undersea, and land systems, military vehicles, and other systems. And once the acquisition is consummated, Orbit will report through Kratos' microwave electronics division, which is headquartered in Jerusalem, Israel. German satellite manufacturer Reflex Aerospace has closed a €50 million Series A funding round. And that funding round is actually the largest Series A in the European new space sector to date. Reflex says that the new capital will accelerate the development, production, and deployment of sovereign satellite constellations, providing optical, synthetic aperture radar, space domain awareness, and signal intelligence capabilities. Part of the financing will be used to expand existing manufacturing capacity in Bavaria to manufacture satellite constellations for intelligence and communications purposes. Reflex Aerospace aims to have all capabilities ready for deployment and demonstrated in orbit by 2027. Starcatcher has set a new world record for wireless optical power transmission. The space power company recently completed a series of optical power beaming tests at NASA's Kennedy Space Center to validate core technologies for its orbital energy grid, the Starcatcher network. Using an advanced suite of multi-wavelength lasers, the team delivered more than 1.1 kilowatts of electrical power to commercial off-the-shelf solar panels at Space Florida's launch and landing facility. The most recent record high was 800 watts set by DARPA in May 2025. So records are being broken every day, doesn't it seem? Starcatcher delivered more than 10 megajoules of energy throughout the test campaign, and the company says that the tests demonstrate readiness to power customer missions in orbit. Starcatcher will launch its first on-orbit power beaming demonstration in 2026. And speaking of 2026, Portal Space Systems has introduced a new spacecraft, which they plan to launch to orbit in 2026. Portal's Starburst is an ESPA-class rapid maneuverability spacecraft. The Starburst 1 will be the company's first free-flying mission with live payloads, and it is expected to launch on SpaceX's Transporter 18 in Q4 2026. The mission aims to demonstrate rendezvous and proximity operations, rapid retasking, and rapid orbital change for national security and commercial use cases. The company says that the spacecraft will be available for customer missions in 2027. And that concludes today's top 5 stories. But as always, there are so many more stories that could have made today's Intel briefing. And N2K senior producer Alice Carruth joins us now with a look at those other stories that are making today's headlines. Alice?
Thanks, Maria. Firefly has completed their acquisition of SciTech. Leidos has been selected to lead Starlab's US-based assembly, integration and testing activities for the commercial space station. European startup eCosmic is having its flagship space domain awareness solution, SAFE, tested by the European Space Agency on a selection of ESA-operated satellites. Raytheon UK has been awarded a contract to provide orbital analysts in support of the UK Space Domain Awareness mission. And iSpace has been selected by Japan's Space Strategy Fund for a project titled Establishing Surveying and Ground Investigation Technologies to Realize Lunar Base Construction. You can read more about these stories and all the others mentioned throughout the episode by following the links in the selected reading section of our show notes.
Hi, T-Minus crew. A quick update and thank you from yesterday's show where I asked you if you would be the 3,500th follower of N2K T-Minus Space Daily on LinkedIn, and I'm happy to report that indeed you all were very awesome and listened to that call, and we are now over 3,500 followers on LinkedIn. Thank you very much. And you know, a lot of people are also listening to podcasts through YouTube. And if that is the way that you would prefer to listen to this show, well, I have great news for you. T-Minus Space Daily is indeed on YouTube, and we post our episodes there along with video clips from interviews and events throughout the year. So if you like to dual screen at work and keep the YouTube player going all day while you are heads down, you are certainly not alone. At N2K Cyber is our company's YouTube channel, and when you are there, you will find the T-Minus Space Daily playlist, along with all of the other shows that we make here at N2K, like The Cyberwire and Hacking Humans. So again, if you want to listen to T-Minus Space Daily on YouTube, find us at N2K Cyber on YouTube. And thanks.
What happens when cybercrime becomes as easy as shopping online? SpyCloud's Trevor Hilligoss joined Dave Bittner on the CyberWire Daily to explain how a wave of cybercrime enablement services are lowering the barrier to entry and making sophisticated attacks available to anyone.
I think it's a pretty good general term that describes kind of an umbrella of tools and services that I would kind of tag as criminal or criminal adjacent. Instead of having, sort of the smaller pool of high sophistication actors that are able to kind of carry out these really vast and costly cyber attacks, we see that being given to much lower sophistication, lower tech folks that are, a much lower barrier to entry to get into this field. The person that's buying access to this, they basically need a phone and a Bitcoin wallet.
Make sure you hear this full conversation and learn how the underground economy is reshaping cyber risk. Visit explore.thecyberwire.com/spycloud. That's explore.thecyberwire.com/spycloud.
Our guest today is Yanni Barghouty, co-founder and CEO of Cosmic Shielding Corporation. And Yanni started our chat by telling me more about Cosmic Shielding Corporation.
So Cosmic Shielding, or CSC as we like to call it, has developed a nanocomposite shielding material that we use to build a variety of shielding structures for space and defense applications. And shielding has been an issue in the industry since the Apollo era. Right? I like to say that aside from getting to space, staying there is the next hardest thing, right? Mm-hmm. So the idea with our material is you could have the best shield in the world, but if it's hard to integrate, no one's going to use it. So we spent a lot of time optimizing what we call the secondary properties, so mechanicals, thermals, and so forth. We worked out at the Institute for Soldier Nanotechnologies at MIT for some time until we got our own facility. And essentially what we've enabled is for customers to be able to take anything that you would use on Earth, whether it's a COTS device, like say an NVIDIA GPU, solid state drive, or even a biological system. And use it in orbit safely and reliably. So essentially, in short, what we do is try and bring Moore's Law to space.
Fantastic. And I remember, I'm going back about a year when we last spoke, I think we were talking about the opportunities that shielding, like what you all provide, can open up specifically in the realm of AI, if I'm summarizing that conversation from a year ago correctly. And I know there's been some announcements rather recently about some new awards that you all got. Could you tell me a bit about that?
Yeah, so last time we were on the podcast, we were discussing the NVIDIA mission that we were doing with AFRL and Aethero. We were taking an NVIDIA Jetson GPU and shielding it and showing that you can have essentially significantly reduced error rates without having to harden the chip using traditional radiation hardening techniques and so forth. So that was a success. Throughout the past year, we've demonstrated not just with the on-orbit mission, but many terrestrial examples of that same NVIDIA system. Well, not the exact same one, of course. We had a very large sample size of systems to fry at the accelerator facilities. We didn't fry all of them, of course. So we tested shielded and unshielded and then aluminum shielded structures at HIMAC, which is the Heavy Ion Medical Accelerator in Chiba, Triumph, major accelerator in Vancouver, and then at NASA Space Radiation Labs. And at each case, we were able to show a significant near order of magnitude reduction in single event effects, as well as what was more interesting to me, a reduction in the actual severity of events that do occur. So that's something that is difficult to predict, right? So if you're trying to do a simulation and trying to see that, that's something a lot of people would have missed even up until now. And that takes us to the new award. So we had support from Space Systems Command and AFRL to essentially take what we did there in that mission with the NVIDIA chips and take it a step further, generalize it to anything, essentially, any new COTS system, any modern COTS hardware, and some traditional radiation tolerant and radiation hardened components. And not only showcase, the efficacy, because it's predictable for us, we know we can make it work. It's how do we predict exactly how well it's going to work? That's the next step. So we're taking all these other systems and we're screening them extensively through the same process as we did with the NVIDIA boards, and using that data to build essentially a model, so a semi-empirical software tool to be able to quickly diagnose the shielding requirements for future hardware. So now that we know we can shield it, we need to see how much shielding it needs, right? And instead of having to take chips to particle accelerators and spend hundreds of thousands of dollars on the low end just characterizing and de-risking the system, imagine if you could just take those chips and do a simulation. Right? So there's a huge gap in simulating the effects on the chips. We can simulate the environment, right? That's very, very well understood physics and very comprehensively done, let's say, in the industry. But taking that data and then applying it to the actual error rates, there are old tools people use, like one called Cream 96, for example. It's an old tool built by Vanderbilt during some time working with, they worked with quite a few people, but NASA SRAG is an example, the Space Radiation Analysis Group, where they were trying to essentially say, okay, how can we take that radiation field data and guesstimate how a chip will react? The problem with that is that it was built, as the name suggests, in the 90s, right?
Yeah.
And anything below something like 90 nanometers, it cannot give you an accurate representation, right? So every single COTS device, for the most part these days, is well under 90 nanometers, right?
Yeah.
So essentially, we're updating that, but also making it a little more sophisticated, being able to incorporate advanced shielding into the simulation. So yeah, that's essentially what the TACFI is. We actually maxed out the commit from the Air Force side, $2 million there, and then we had another $2 million from which is a little interesting and unique, rather than from a VC match, because TACFIs are a public-private matching program.
Yeah.
We actually have it exclusively from customers, right? Just because there has been a very high demand ever since the announcement of the NVIDIA mission last year.
Well, congratulations. That's huge.
Yeah, no, it's exciting because essentially for us, it knocks two birds with one stone, right? Like how the phrase goes. It allows us to do what we need to do for TACFI and get the data we need to do from all these diverse range of systems, while at the same time also de-risking shielding designs for actual customers.
Speeding things up significantly also, updating these models that have been outdated for decades and being able to simulate at a scale and a level of sophistication that we just haven't had. That is a many-decade advancement. That's huge.
Yeah, exactly. It's exciting for us, and it's going to be in quite the ordeal. Like, don't get us wrong, but we've already started the project in terms of starting the initial beam tests. So we have hundreds and hundreds of hours of accelerator time at NASA Space Radiation Labs, HIMAC, all the other CERN. Actually, that's one of the more exciting ones. And now the work begins, and the exciting thing that I'm looking forward to is that you hear all this talk about data centers in space nowadays.
Yes.
Right? The idea of, we want to put, it makes sense for the sake of saving power, lowering the environmental impact, put these data centers in orbit. But in order to keep up, right, their on-orbit surfacing is going to have to be a core component there, right? Updating the hardware as it goes. But to update the hardware, you don't want to have to spend years de-risking it in an accelerator facility. So that's the exact type of application or example user base that would benefit from this work. Another one that is less, I'd say less on the commercial side and more on the defense side, is that there's a huge shortage of rad-hard parts for defense applications. And as, we trend towards, I'd say, there's some stability changes in the world, of course. Yeah. There's some concerns over missile defense systems and so forth. Right?
And so forth, yep.
The ability to essentially take COTS components and quickly de-risk them to be used in these high-risk applications that can be exposed to a high radiation environment or have just an extremely low tolerance for a single event effect. So, for example, if you have a missile defense system, there's one single event effect, right? You're talking about a very short flight time. So a single error that causes a reboot on the system, totally
catastrophic.
So that's actually an area we've been getting a ton of support from the government. And we were actually recently awarded, which we'll go into details on this at a later date, but we were actually awarded a sole source contract to pursue some of that qualification alongside what we're doing with the TACFI.
Wow.
So I think it's a sign because, even last year when we last spoke, the there was quite a bit of an increase on attention towards COTS and even shielding, right?
Yeah.
And now it's almost becoming mainstream. The idea of like, okay, shielding might actually be the way to go with a lot of this hardware. There was a gap where I think the industry had a little bit of a stasis with innovations in the field, just mainly because there was a status quo. Right? You used rad-hard chips or you used COTS chips for like a CubeSat mission that's only going to last a year or two.
Yes.
Right?
Yep.
No, right. So now we're seeing all the fruits of all these new developments. Right. It's a really exciting time.
So we're making missions last a lot longer, more dependably, and that dollar goes further, so to speak, for all involved. So. Yeah, I mean, I come at this as an ex-computer science person and married to a computer science guy. And often when we think about edge computing in space, just the edge in space, so to speak, data centers in space, usually the first question that when we're talking about this over the dinner table is, well, what is radiation going to do all to these extremely sensitive, really tiny components? And it's just really cool knowing that like you all are working on something that is such an important component to this incredible infrastructure that is being built right now in space.
Absolutely, I appreciate that. And there's a lot of changes going to happen over the next year as well, because now that we've been hitting our stride essentially with our general operations of, we're delivering materials at a weekly basis now to a variety of applications. And now our plan, in addition to what this TAC file will allow, the TAC file will allow us to quickly diagnose right, the requirements for virtually any mission, the work product from that TAC file. We are now developing essentially all-in-one. So rather than having engineers work to figure out how do I even integrate this material in these applications, we're developing ready-to-go coated variants of the material that have whether gold, tantalum, aluminum, all sorts of different materials coating the outside of the layers, allowing you to essentially use it at any form factor beyond what we're currently doing. So essentially, we focus on the actual chip level or inside the system, right?
Yeah.
We're now going to be releasing structures for bus manufacturers, so full replacements of larger structures, even satellite elements like the bus element, used as essentially an all-in-one. So basically significantly improve the performance of the shielding itself, just because we can design the actual enclosure rather than having to work around existing restrictions.
Right. That makes sense.
Simultaneously giving significantly streamlined integration. So that's what we're working on in parallel with all this over the next months. We're hoping to launch these early Q1, early next year, I would say.
We'll be right back.
Hey there, it's Dr. Sanjay Gupta with some exciting news to share. CNN is now streaming. That means you can read, watch, and stream everything in one subscription. You can watch news live 24/7. You can also explore catch-up videos and explainer videos. And you can also watch a library of CNN's originals, including my latest documentary, It Doesn't Have to Hurt. Just go to cnn.com/all-access.
Welcome back. Credit where credit is due when it comes to clever headlines. Applause, 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 please, for Popular Mechanics for this one. Scientists think this space object could be from a dead civilization. Now, that headline is quite clever because if you think it's about the interstellar comet 3I Atlas that's been making a lot of headlines lately for its appearance, you would be wrong. No, this is not about that interstellar object at all, nor is it about everybody crossing their fingers that maybe it's actually aliens because, hint, it's never aliens. No, indeed, this is about a totally different object. Object Arjuna 2025 PN7. Yes, a totally different thing. Arjuna asteroids, for context, are a group of near-Earth objects, and there are several such near-Earth object groups, but a key thing to remember, near-Earth object. Okay, so indeed, this Arjuna object of interest, like its compatriots, are often called quasi-moons or quasi-satellites. And going back to that funny headline from Popular Mechanics about this object being from a dead civilization, there are no sci-fi revelations to be had here. The dead civ they're referring to is the Soviet Union. Back to the USSR, baby. There are signs that this object, Arjuna 2025 PN7, is actually not a near-Earth rock but a near-Earth bit of space debris that we all kind of lost track of and has come back to say hello. It is entirely possible, if not entirely likely, that this object is actually from a failed USSR mission to Venus in April 1967, the Zond 1. And if you are thinking, because you are a very smart listener, dear T-minus listener, hey, didn't we also have another failed USSR mission to Venus doing some space debris type stuff not that long ago? You are very, very smart. Yes, you would be correct. Indeed, that was May 10th, 2025, when the Cosmos 482 descent craft for a Venera mission to Venus came back to Earth. 53 years ago, that USSR mission never left Earth's gravity. In contrast, the Zond 1 mission, which was actually a predecessor to the Venera missions, actually did get within 100,000 kilometers of Venus, but a lot of its onboard systems had already failed by that point. So if this object is from Zond 1, it'll be interesting to see that the two USSR-era missions to Venus have in some way made their way back to Earth this year. Makes you wonder, is Venus trying to tell us something? And that's T-Minus, brought to you by N2K Cyberwire. We'd love to know what you think of our podcast. Your feedback ensures we deliver the insights that keep you a step ahead in the rapidly changing space industry. If you like our show, please share a rating and review in your podcast app. You could also fill out the survey in our show notes or send an email to space@n2k.com. We are proud that N2K Cyberwire is part of the daily routine of the most influential leaders and operators in the public and private sector, from the Fortune 500 to many of the world's preeminent intelligence and law enforcement agencies. N2K helps space and cybersecurity professionals grow, learn, and stay informed. As the nexus for discovery and connection, we bring you the people, the technology, and the ideas shaping the future of secure innovation. Learn how at n2k.com. N2K's senior producer is Alice Carruth. Our producer is Liz Stokes. We are mixed by Elliot Peltzman and Trey Hester, with original music by Elliot Peltzman. Our executive producer is Jennifer Iben. Peter Kilpie is our publisher, and I am your host, Maria Varmazis. Thank you for listening. See you tomorrow.